So to solve that equation, given that 2 minus 3i is a root of a cubic equation, root means a solution. It's not a square root, it's a root. So if it's a solution, we just do that. It's the value of z equal to minus 3i. And as you know, the complex root come in pairs, so I have here plus or minus. So that gives us to root. To root means it's make quadratic equation. So to construct a quadratic equation, we just switch that to other side. It will be z minus 2 is equal positive or negative 3i. Now we squared both sides. Why we squared both sides? To remove I. Perfect square, first squared, it will be z squared. Minus, first times second times 2, it will be 4z. Second squared, it will be positive 4. In other side, negative or positive squared, it will be positive 9i squared. So I squared cancelled, and we changed the sign of 9, rearrange the equation. So that means z squared minus 4z plus 4, all of that. Sorry, 4 plus 9, it will be plus 13 is equal to 0. So since 2 plus or minus 3i is a factors or is a root of that equation, so that means the cubic equation divisible by that quadratic equation. What's the meaning of divisible, mister? When we divide, we get 0 as remainder. So now just divide that. The cubic equation, it's z cubed minus 6z squared plus 21z minus 26 divided by the quadratic equation z squared minus 4z plus 13. To make long division, we have three processes: dividing, multiplying, and subtracting. Always we dividing first term in dividend by first term in divisor. So just do that. Z cubed divided by z squared, it's equal to z. Then multiplying that z by every term here. Z times z squared, it will be z cubed. Z times negative 4z, it will be negative 4z squared. Z times 13, it will be 13z. Now subtracting means we change the old sign of subtrahend. That positive, it will be negative. That negative, it will be positive. That positive, it will be negative. Then we just adding. Positive z cubed divided minus z cubed, it's cancelled. Negative 6 plus 4, it will be negative 2z squared. 21 minus 13, it will be negative 21 minus 13, it will be negative 8. So positive 8, sorry. Now we didn't use negative 26, it goes down. Divide again, first by first. 2z squared divided by z squared, it will be negative 2. Now we multiply that negative 2 by every term. Negative 2 times z squared, it will be negative 2z squared. Negative 2 times negative 4, it will be positive 8z. Negative 2 times 13, it's negative 26. Subtracting means we change the whole sign of the last one. Now we just collecting like terms. All of them cancelled. One positive, one negative. So the remainder is 0. He said here, find the other roots. So the other root is the conjugate of this because it's complex, and we take quotient to equal it by 0. So the other root, it will be x minus 2 is equal 0. So shifting that to other side to state the value of x, which is equal to. So what is the other root now? It's 2 plus 3i, the conjugate of the complex given root, and the real value, it's x equal to. Also, unlike that question, if the given only real, for example, he said here z equal to or 2 is a root. So that means we will divide the cubic equation by x minus 2. Then solve the quotient, and the quotient here, it will be the quadratic equation, which is z squared minus 4z plus 13 equal to 0. Sorry, it's z, not x, because the variable is given z. And that is the final answer. So if he changed that and put 2 is the real number, so we just divide by x is equal to, so we're shifting that, I will divide by x minus 2, and the quotient here, it will be that quadratic equation. Then we will solve that quadratic equation using the formula. Practice questions. Here if he said z1 equal 3 plus I, z2 equal negative 5 plus 2i, work out z1 plus z2 and z1 minus z2. We get like that questions in multiply choice. In z1 plus z2, we're just adding real in z1 with real in z2. 3 minus 5, it will be negative 2. 1 plus 2, it will be 3i. If you want to find z1 minus z2, we're just subtracting real minus real. 3 minus 5, it will be 3 plus 5, 8. 1 minus 2i, it will be negative 1i. If you face any problem inside the exam, you need to read the question very well, because the given have the case of the answer. So by first writing z1 times z2, so that refer to multiplication. 3 plus I times negative 5 plus 2i, and then expanding brackets and using the fact I squared negative 1 to show that. So I want to show the multiplication is equal, so we just need to multiply. So z1 times z2, it's only multiplication. 3 plus I times negative 5 plus 2i. In multiplication, we just distribute normally using multiplication, first term by every term in the second bracket. 3 times negative 5, it will be negative 15. 3 times positive 2, it will be positive 6i. Then take the second term, I times negative 5, negative 5i. I times positive 2i, it will be positive 2i squared. And as you know, I squared the negative 1, that cancelled, so I got, collecting now real with real, negative 15 minus 2, it will be negative 17, where that is the real. After removing I, it's changed to negative 2. 6 minus 5i, it will be positive 1i, so I got the same answer, it's proven. Next, given that z1 equal 3 minus 2i, z2 equal 4 plus 3i, write down the conjugate of each of which. So as you know, z1 conjugate, we just change the sign of imaginary part, it will be 3 plus 2i. z2 conjugate, it will be 4 minus 3i. We change the sign of imaginary part. Letter B, show that z1 times z2 conjugate. So as you know, z1 is given, that is z1, so it will be 3 minus 2i, that is the value of z1, times z2 conjugate from here, that is 4 minus 3i. So it's equal, just expand, 3 times 4, it's 12, 3 times negative 3i, negative 9i. Now distribute negative 2. Negative 2i times 4, it's negative 8i. Negative 2i times negative 3, it's a positive 6i squared. And as you know, I squared cancelled, and that changed to be negative. So it's equal 12 minus 6, it will be 6. Now take imaginary parts, negative 9 minus 8, it will be negative 17i. So I got the same answer. Here, and he said z2 times its conjugate equal 25. So I told you that before, any product of any complex number and its conjugate always give us only real part, x squared plus y squared. Don't forget that. We use it in division. So if you wanted to explain or to elaborate why that happened, you can multiply it normally. z2 here is equal 4 plus 3i. And the conjugate of it, it will be 4 minus 3i. Start to multiply, 4 times 4, it's 16. 4 times negative 3i, negative 12i. 3i times 4, it will be positive 12i. 3 times negative 3, negative 9i squared. So that one positive and the one negative, it's cancelled. And I squared removed, and that it will be plus. So it's equal 16 plus 9, where it's 16 represent 4 squared and 9 3 squared. So the answer it will be equal 25. So the next question, given Z1 is equal, Z2 is equal, Z1 plus Z2 is equal, find the values of A, B, where A and B are real numbers. Oh, it's a very good question, and it's easy also. We just need to follow the rules. He said here, that is the value of Z1, that is the value of Z2, and that is the given. And always we start from the given, since Z1 plus Z2 is equal 1 minus 3i. And everyone know, when we have two complex number equal, so the real parts are equal and imaginary parts are equal. So we will adding Z1 and Z2. So here, that is the real part, and here, that is the real part. It's unknown, mister. So we just do that. We adding real in only one bracket. Then take I as a common and adding imaginary in other bracket. All of that is equal 1 minus 3i. Now, what is the real in Z1? It's a negative 7. The real in Z2, it's a positive 8. So we just do that. Negative 7 plus A. That represents the real of that complex number. Now we are going to the imaginary in other one. The imaginary here, it's 6i. The imaginary here, it will be pi, where I is a common. So we're just adding the coefficient. It will be 6 plus p. Now I have to equal complex number. We just equate real in both sides. So when we equate the real, the first one, negative 7a is equal 1. So you can find the value of A here. A equal negative 1 over 7. So equate the imaginary by the same way also. So when we equate the imaginary, I got 6 plus p. Sorry for that, the previous one here. It will be negative 7 plus A equal 1. So A equal 8. It's shifted to other side. In the second one, 6 plus p, the sign here are different. So it will be equal negative 3. So the value of B is equal, shifting 6 to other side, negative 3 minus 6, it will be negative 9. So that is the values of A and P. In this question, he said, given that Z2 equal 5 minus 3i, and that non-real roots. So it's a complex, it's clear. It's a complex, it's non-linear. And as you know, the complex number come in pairs. Two quadratic equation with the real coefficient always occurred in a complex conjugate pairs. Find the equation. So he gave me the square root and want us to construct the quadratic equation. So as you know, z is equal 5 minus 3i. So we change the real with z to keep I alone inside. So it will be z minus 5 equal negative 3i. And that it will be positive or negative, positive or negative. To remove I, we just squared both sides. Here I have perfect squared, expand it, first squared, first time, second times 2, it will be 10z. Second squared, it's positive 25 is equal. In other side, positive or negative squared, it will be positive, 3 squared, 9i squared. And as we know, I squared cancelled that, it will be negative. Shifting that to other side to write it in standard form. So z squared minus 10z, 25 plus 9, it will be 34. All of that is equal to 0. That is my quadratic equation. So here the root or the complex root is given, and as you know, the complex root come in pairs. And he asked to construct the equation. We just do that. Now in the next equation, he said fz is equal z cubed minus 9z squared plus cz plus d. I have unknown here. I have two unknowns, c and d. So it's good. Where c and d are real numbers, no problem. The roots of the equation means the solutions. That is cubic, so that means you must have 3 roots. He gave us 1 real and 1 complex. And as you know, the complex root come in pairs. So I have the 3 roots, all of them. So you can construct the cubic equation and compare it with that. How that? First of all, z equal 3. So that means in the real, z minus 3 is a factor. Factor means fx divided by that factor with remainder equal to 0. Now we're going also for the complex root, z is equal 3 plus or minus r. Construct the quadratic equation. So it will be z minus 3 is equal positive or negative r. Squared both sides. So it will be z squared, first time, second times 2. Second squared positive z, positive 9 is equal. Positive or negative squared, it's positive, and I squared, it will be negative 1. Shifting that to other side, so the quadratic equation here, z squared minus 6z plus 9 plus 1, it will be positive 10, is a factor. So if you have factors, you can find the fz by multiplying that factors together. Their product give us the cubic functions. So it will be equal z minus 3 times z squared minus 6z plus 10. Expand normally. Take first term, distribute it by every term in the second. Z times z squared, it will be z cubed. Z times negative 6z, it will be negative 6z squared. Z times positive 10, it will be positive 10z. Now we take the other factor, negative 3. Negative 3 times z squared, it will be negative 3z squared. Negative 3 times negative 6, it's a positive 18z. Negative 3 times positive 10, it will be negative 30. Now, collecting like terms, I have only one term involving z cubed. Here, for squared, negative 6 and minus 3, it will be negative 9z squared. For terms involving z, I have here positive 10z plus 18z, it will be positive 28z. Finally, the constant value, only one value, which is negative 30. Now compare that with the given. In the given, I have z cubed, it's a given. Negative 9z squared, it's a given. Cz, so the value of c here is equal positive 28. So c small is equal 28. And also, the constant value here d, here it's negative 30. So the value of d equals negative 30. Then hashtag we love math. To find z1 divided by z2, 2 minus I, we multiply and divide by the conjugative denominator, which is 2 plus I, 2 plus I. It's equal, first squared, 4, 1 squared, it will be 1, 5 times 2, 10, 5 times I, it will be 5I, 7I times 2, it will be 14I, 7I times I, it will be 7I squared. That cancelled, it will be negative. Here I have 5. 10 minus 7, it will be 3. 5 plus 14, it will be 19I. Then split, it will be 3 over 5 plus 19 over 5I. And next one, z1 equal 3 plus ai, z2 equal b minus 7i. The adding equal that value. Find the value of a and b. So we're just adding z1 and z2, real with real. 3 plus the real here is b. So it will be 3 plus b as a real inside bracket, plus we take I as a common factor. We're adding imaginary with imaginary. The imaginary here, it will be a. The imaginary here, it will be negative 7. And we take I common factor outside. It's equal 14 plus I. Now equate real. So 3 plus b is equal 14. So we can state the value of b by shifting 3 to other side. It will be 11. Equate the imaginary. So a minus 7 is equal 1. Shifting 7. So a is equal 1 plus 7. It will be 8. Solve the following equation. We did like it. Here solve using completing the square or using the formula, and it's better to use the formula here. You can practice it alone. We solve like it. The next one, given that 7 minus I is one root of the quadratic equation with real coefficient, write down the other root. That is a complex root, so the other root, it's a conjugate. It will be 7 plus I. Find the equation. So I want to construct the equation. We just do that. The variable here is z is equal 7 plus or minus I. Shifting that, it will be z minus 7 equal positive or negative I. Squared both sides. So I will expand that perfect square. Z squared minus first time second times 2, it's 14z. Second squared, it's 49. All of that is equal. I squared is negative 1. So the equation, it will be z squared minus 14z. 49 plus 1, it will be plus 50 equal 0. And like that question, he said, where b, c are real constants, so we can start the value of b by comparing that with the given equation. So the value of b here, it's equal negative 14. You need to find it. The value of c, it will be equal 50. Then hashtag we love math. And the next question, we did like it before. It's a cubic equation involving two unknowns, c and d, where the given one real root and one complex root. So you can construct the equation by finding the factor. So when z is equal negative 2, so that means z minus z plus 2 is a factor. And also z is equal, in complex root come in pairs, 4 plus or minus I. So to construct the quadratic factor, shifting 4 to other side, it will be z minus 4 is equal positive or negative I, squared both sides. So it will be z squared first time second times 2, 8z, second squared 16. All of that is equal negative 1. So the quadratic factor here, z squared minus 8z, shifting that plus 17 equal to 0. Now, to find the cubic equation, we just multiply that factor together. Z plus 2 with the quadratic factor. Expand that, then collecting like terms like we did previously, then compare with the given equation to state the values of c and d. It's a very good question here. It's tricky. Given z is equal negative 3 plus 4i, show that x squared minus y squared equal negative 3 and the 2xy equal 4, and that equation's coming only from square root. So let z here is equal negative 3 plus 4i. And as you know, z represented by x plus I, y. So if we square both sides, we will get here as a real part x squared minus y squared plus 2xyi, and that it will be equal, first squared it will be 9, first time second times 2, it will be negative 24i, 3 times 4 12 times 2 negative 24, second squared it will be 16i squared. So as you know, I squared here, it will be negative. So that means x squared minus y squared, it will be plus 2x y I is equal 9 minus 16, it will be 9 minus 16. So here 9 minus 16, it will be negative 7 minus 24i. Now equating real, so I got x squared minus y squared is equal negative 7. Equating imaginary, but 2xy is equal negative 24.